All right, guys, you guys just had 3 days off. So what you guys did with your 3 days? Anybody do anything epic? Yeah.
Went to Bush.
Yeah.
How many of you went to Bush? Yeah, so did you guys go together?
Yeah.
Wow, that's cool. Anybody do anything else? Anybody not in the Bush group that wants to?
That's Lumberg.
So at the highest point, or apex, the horizontal velocity still exists and is constant, but the vertical velocity, which is totally separate, is 0. Again, that's at the apex. What is the idea of taking? Would everyone please go to their test-taking positions?
Run.
Of canon problems. Any? Let's utilize this wildly inappropriate example of a canon problem to learn more about it. So,
the initial velocity is 2 meters per second and theta is 30 degrees. The first thing we need to do is break the initial velocity into x and y components. The component is given by Vy equals Vi sine theta. Plug in the given, so Vy equals 2 meters per second sine theta, which gives us a Vyi of 1.09 meters per second. To find the x component, we use the equation Vx equals Vi cosine theta. Plug in the givens again, so Vx equals 2 meters per second cosine theta, which yields an answer of 1.68 meters per second. From there, we can use the equation V at the apex, Vyi plus At up, to find the time it takes to go to the apex. At the apex, the y velocity is 0, and we know that Vyi is 1.09 meters per second. We also know that the acceleration is negative 9.8 meters per second squared. Given that information, we can solve for t up, which is 0.11 seconds. By symmetry of motion, t up equals t down, so t down is also 0.11 seconds. We can now find t tot, which is equal to t up plus t down. This gives us a total time of 0.22 seconds. Also, because of BSUM, the final velocity equals the initial velocity, but in the opposite direction. So the final velocity is equal to negative 2 meters per second.
NANI?!
so folks, does anybody have any examples they'd like us to analyze for the class?
The Vyi equals 0 meters per second, Vx equals 0.5 meters per second, and the initial height is 20 meters. We will use the equation Vyf squared equals Vyi squared plus 2ad to solve for Vyf. Plug in the givens and make the height negative. This gives us a Vyf of 19.81 meters per second. Since we know the Vyf and Vx stays constant, we can solve for Vf using Vf squared equals Vyf squared plus Vxf squared. We know the values of Vyf and Vxf, which are 19.81 meters per second and 0.5 meters per second respectively. Solving the equation for Vf yields an answer of 19.82 meters per second, but you have to remember to make it negative, so the final answer would be negative 19.82 meters per second.
Did it wrong.
All right, everyone. Dude, you messed the clip up. Why the